This topic in the past has been given by others. Notably, last year and the year before, we had a wonderful presentation from Alejandro Tomas from True Leaf Farms. So he focused a lot on leafy greens, and you'll notice that I put many slides from him, and you'll recognize the difference in style. So the more professional looking slides are obviously his, all right? And so he gave the talk on pre-harvest factors, so I just added a few other things and modified it slightly, okay? But remember, we're interested in fresh cut, right? Okay. So, we have those quality attributes that we were talking about. And in our fresh cut products, what is the quality, the causes of quality loss? We talked about that in some of the other presentations. But his important point here in this slide had to do with raw material quality. And this is something I think we all struggle with, right? Okay, how do we get consistent raw material quality? Talking to anybody in a specialty fresh cut item, and even lettuces, about which we know a fair amount, it's a constant battle about having consistent raw material quality, okay? But here, the important point is that we can't improve that raw material quality. We're just trying to maintain its quality, right? I'm going to change the order, and I'm going to talk a little bit about maturity first, and then talk about those other pre-harvest factors, okay, or some of the pre-harvest factors. Beth Mitchum already talked to you about maturity, especially as it relates to fruit. So I'm going to focus on horticultural maturity, which applies to most of our vegetables, yeah? And so we use some of the same terminology, although the actual definition then in fruits, we're interested in a very specific physiological stage, whereas in vegetables, it's more operational. It depends on what stage we want to harvest that. Do we want to harvest, say, true baby carrots, or the mature carrots and cut them up into baby carrots, for example? But we can use the terms immature, mature, and overmature when we talk about the vegetables, but they're going to mean something quite different than the same terms applied to fruits, okay? But I think we all have that concept. This was harvested too mature for our needs, right, in the vegetables. And Beth Mitchum also showed something very similar to this, which is called the developmental continuum, right? And I'm just going to populate it with a few examples of different products, right? So again, the idea that in our vegetables that might end up being fresh cut, say cucumbers or the beans or sweet corn, those are going to be in a very rapid phase of growth, and therefore their changes in maturity are going to be very fast compared to something like potatoes and onions that have reached more the full mature stage, okay? So just keep that in mind. Whereas again, on the fruits, we're talking about fruits, we're always talking about them having reached the stage of maturity and then going through the ripening process. But in vegetables, we're really harvesting them at various stages of development. And the younger they are in their development, then the higher their respiration rates, the more perishable they will be, okay? Keep that in mind. Okay, so now a little bit about maturity. These were, the photo was actually, mine. But here talking about what are indicators of maturity in lettuce. So what do you think are the indicators? I mean, they're listed there, right? The size, the number of leaves, the diameter. One is the density, we say, or compactness, but one that's not there would be sort of the density, right, okay? And there's another, it is mentioned there, core length, okay? The core length. So as it's hard to see on this slide, it's not very consistent, but that core will increase as the product becomes over mature. And again here, so here if we cut it off to be similar, these aren't cut really properly, okay? But here you have less core, and the core will increase with time. Not very good photos to illustrate that. But let me ask you a question. Okay, so you're going to cut lettuce into salad, okay? So which stage of maturity do you want? Which number? Oh, you want number 1? Wow, I'm going to buy your salads, okay? All right. All right. 3? All right. Anybody want more than 3? Okay, so one of the points that he makes, and of course they use, they do a lot of lettuces and leafy greens, is, okay, this is a little bit different photos, okay? But, so, the impact of maturity on fresh cut produce, and these are sort of generalities based on research and also real life observations, okay? And so if it's on the immature side, which is a delicious lettuce, but will have higher respiration rates, okay? So that, the packaging may be a bit of a problem because the packaging is going to be designed for, all the lettuces. And here, you may get more decay because that tissue is more tender, is more easily bruised, it's more easily damaged. So there are some companies that just plain tell me they would go with a 4, for example, because that's more robust, it's got more fiber, right? So that young green leafy tissue many times doesn't perform as well. Although, strictly speaking, from a salad standpoint, that's going to be the most delicious salad, right, okay? Then we say mature, so that would be that number 3. We say optimum maturity. That was his opinion, optimum maturity. The best stage for fresh cut. And that's probably where I would say the industry generally is headed. Would anyone disagree with that? Would you agree with that? Yeah? Again, yes? Mm-hmm.
Dependent of the mature stage of the
yes. Exactly. So the criteria there in terms of flavor and things overrides shelf life. Whereas here in the States, sometimes it's the shelf life that's driving things, okay? Yeah, very good point. So, all right. And then if it's on the over-mature side, so poor shelf life, developments of off odors, but here he says rapid breakdown. By breakdown here, what we mean is browning. So the more mature the lettuce, we have more phenolics, and we're going to have more trouble with a cut-edge browning than in the immature tissue. So there are implications regarding the maturity, okay? Now here's an example that we did. This is within a lettuce head. So what we had were a bunch of romaine. This is romaine. And so this has to do with leaf position, because remember in our leafy greens many times, especially when we have heads of lettuce, or that the leaves are at different stages of maturity. So it's actually quite complicated. So we have young growing leaves, if we go back to these heads. The young growing leaves are right here, right? These are new leaves being put out. The older leaves are on the outside, right? Okay, so as a head becomes more mature, you keep putting out young leaves, but it becomes very compact, right, as it adds more leaves, okay? So here what we did on a romaine is we separated the leaves, the inner, the heart leaves, the young leaves, the mid-size, and the full size. These were cut, and then they were stored for, 7 days in air, and I didn't put the temperature, but I'm pretty sure it was at 5 degrees Celsius or 41, okay? So what do you conclude from that in terms of the effect of maturity? Remember, now we're talking about the heads, but we've separated out the leaves that are different stages of maturity. So how important is leaf maturity on the browning in that romaine heart, and the romaine head, sorry? Is it important? Yeah, clearly, right? Okay. So in other words, if you have, now these full-size outer leaves, usually in cut operations, those would be eliminated. They would have been trimmed in the field. So that's sort of an exaggeration, but just to show you the continuum. But certainly these mid-sized leaves are going to end up being cut. Those are going to brown more. And you can see the heart leaves hardly brown at all. So as the leaves develop, what happens? They accumulate more phenolics. And so it's going to be, they'll brown more easily, right? Now, in practice, that browning is controlled by temperature and temperature's good. Always say temperature first, okay? All right, good. Temperature and what else to control the browning? Yes, modified atmosphere packaging, okay? So it has to be the combination, temperature with modified atmosphere packaging to control that. But if we were only packaging these very young, tender leaves, you can see we wouldn't really need the modified atmospheres, right? Okay, all right? So the importance of maturity. Here's an example on kale. So this is a brassica. The brassicas tend to be more perishable than the lettuce group, okay? The endives, the escargots, the lettuces, those sort of are one group of perishability, and your brassicas, your broccoli, your kale, your mitsuna, arugulas, all of those are much more perishable, right? Okay? So now here we have, I want to ask you, how many of you like grafts like this? Do they make sense to you? Do you like grafts? Raise your hands if you like them. Yeah? And how many of you don't like them? So I'm really happy with you guys. Oh, Jeff Brack, you like grafts. Come on. Okay. I'm really happy that so many of you like grafts, because many times people say, no, I don't like grafts. For me, grafts are wonderful. Why? Because we can put so much information on a graph, and the more you study it, the more you can extract from the graph, okay? So here we have mature kale leaves, and on the right we have immature. And that's basically based on size. You know that when you go out to harvest kale on the plant, you're going to have leaves at different stages, right? And we go out multiple times to harvest from the same plant. So here we harvested based on size, okay? And there are 3 sizes. You can see immature, the mature, and these are over mature, already showing some incipient yellowing, okay? So those really have no shelf life. So we worked with the mature and the immature. So what you can see is, let's take 5 degrees Celsius or 41, and you can see the difference, how the behavior of the immature versus the mature leaves, okay? Yeah? And so that's very common in leafy greens, okay? On the lower end of the maturity, and true of a lot of the green vegetables, we're going to have better shelf life than if they are more mature. Remember, in the lettuce, what I was talking about before is more the performance of the immature lettuce for the processing, right? You know, cutting it, that type of thing. But strictly speaking, from a physiological standpoint, the immature tissue we're able to store for longer periods of time. And then you can see, also here, you can see the impact of temperature, but here we're trying to separate out the difference in the maturity, okay? And in this case, it's a scale based on these color stages, right, that we're looking at. Okay, so then we did another work. This is a particular kale, a lacinato, and this was a graduate student, Karen Albernis. And so we were looking at the effect of stage of maturity on the fresh cut product. So we cut it up into salad-sized pieces. And then we had immature, mature, over mature based on length and based on width, okay? Here you can see also the pictures, okay? So you know when you harvest them, they look very similar, just they're different in size, yeah? Okay? So then what happened, we cut them. Here's the immature, day 0. And then we're storing them, and you can see one is, it may be hard to see here, but the immature, I'm sorry, we have 2 temperatures. So we have immature, mature, over mature. And then we stored them at 2 temperatures, 32 Fahrenheit and 41 Fahrenheit, okay? So this section, 32 Fahrenheit, and here. And the number of days are different. So here's 14, 28, and 42. And here we have 14, 21, 28. So when you actually look at this, it looks like, wow, there's not that much difference, but there is. Our time frame is completely different, right, okay? So these, at 32, we were looking to see, can we store them up to about 40 days, okay? So you can see that here, at 41 Fahrenheit, here you can see that if they were immature, we still had a product that was marketable quality. But the mature and the over mature leaves did not provide us that. So that's where then you had a separation of maturity. So in other words, what I'm trying to say here is that, for example, at 14 days, we really couldn't tell a difference at that temperature or at 32, right, okay? So that's a short period of time. But as we lengthen our shelf life, if we wanted a longer shelf life, that's where then the maturity will intersect with the temperature and the time in order to show differences. Do we achieve this shelf life or not? No, just trying to show that, okay? Is that clear? I'm kind of stumbling over the words, I know, I'm sorry. Okay, so, and here's some data. Here we had yellowing, and again here, we're at 33, actually 0.5 Celsius because we didn't want to freeze them. So we weren't technically at 0, we were at 0.5. We went up to 42 days, and in this case, at 41, we only went up to 28 days, okay? So, you know, definitely at the lower temperature. But if we look at the 41, then we could see some sorting out of maturity. So the worst performing were the over mature, and then the, you know, they were in between the other 2 stages, okay? So trying to get a little bit at that. So we say that the over mature leaves had higher defects. And then again, we measured the ammonia that we talked a little bit about, and I'll talk more about that tomorrow, okay? Yeah. All right, so I think here the idea behind the maturity is, and I know all of you, I'm sure, pay attention to that, but what are the consequences? When we cut our products and they are at different stages of maturity, what are the consequences of them being at different stages of maturity? How about the broccoli here? How important do you think it is? How important do you think, you know, here we have immature heads, they're less developed, the little florets are very closed. We have what we call mature, and then we have the over mature, and you can see the florets are a little bit larger, right? And eventually they're going to open and make a little yellow flower, right? Okay, so how important do you think maturity is for the shelf life of the broccoli? You think it's important? Yeah, definitely. So many times you'll see the packaged broccoli and you'll see the florets beginning to open or beginning to yellow, etc. And so that, it could be temperature abuse, it could be the atmosphere is not that beneficial, but also I think it really could be related to maturity. There is a big difference among those 3 in terms of their potential shelf life. Now, how about these peppers? The reason I throw these up because, of course, we may want a product that's green, a mature green pepper, and then we may want to be cutting up a red pepper. Are there differences in shelf life between the green and the red? You think so? What do you think? Which one has better shelf life? The green or the red? Yeah, I mean, do you know? I mean, have you worked with peppers? Who's worked with peppers? Yeah? Okay, so do you cut green and red peppers? And which ones have better shelf life? The green have better shelf life, okay. So one of the things, and there's a section on peppers, but I'm not going to give it actually, but let me make the point here is, okay, on the red, one of the tricky things about this is that when we harvest them in the field, we don't want to harvest them red, right? We want to harvest them at what, about 80% red. And that is in order that we cut them just when they reach red. Can you see on this photo here, I have some slices, right? Can you see the difference between the slice on the right and this other slice? See, this slice looks a little bit juicier, the tissue is beginning to break down. That's because that is actually over mature. So if we harvest the peppers red in the field, when did it turn red? Yesterday? Last week? We don't know. So we have to harvest it with some green color in order to know it reached red stage, we're going to cut it. Would you agree with that? Yeah? So that's very clear. So that, again, is where maturity then becomes very important, yeah? And I think more in the red than the green. However, in the green, sometimes people will say we get less shelf life, and that's because they're not actually mature green. They're younger, more tender, like the case of the lettuce, and then they don't perform as well. You have the walls or the cells are just weaker, if you will. So it becomes important that they actually be here really physiologically mature, that they really be fully developed. But we can cut the pepper up from many stages. But if we cut it when it's very young and developing, it will have very poor performance, right? So sometimes when I ask people, okay, which perform better, some will say, oh, green better, others will say red, and back and forth. And a lot of it has to do then with those aspects of the maturity at which they're actually cutting. Okay, so now here we have we have 3 stages of maturity of the romaine, and we have 2 varieties. Can you tell a difference in the performance between the 2 varieties? Yeah? Can you tell? Which one performed better, would you say? There are 4 days at 5 degrees Celsius. Which one performed better? Romaine 1, right? And what's the difference? The browning, right? Romaine 2 browned more. Remember, we're in air, so we don't use a modified atmosphere. We want to see what are the differences among the varieties? And when we do that, we don't want to use a modified atmosphere. The modified atmosphere we know will protect it, but we want to see what are the differences, right? Okay. So clearly, especially if the tissue is over mature, it's going to be worse. And even with mature, you get more browning on romaine 2 than romaine 1. Okay. So here you have a combination of maturity and varieties. And I can tell you through the years working in the fresh cut area, it's like an abyss, right, of varieties, you know, and you just start working in that area, and there's a constant development of varieties and things, and so it's, you know, a lot of work, yeah, to evaluate varieties. But anytime we do a variety trial, we find differences. I think that's the important thing, right? Okay, so we'll come back to the varieties. Now, here are some arugula, and they're held at 32, 41, and 50 for 16 days. Here's 4 varieties, okay? I think we worked with 5, but there's pictures of 4. Now, so the idea there was to look at differences among varieties, right, okay? And that was, the company was interested in that. And my conclusion was, now, okay, so here's the performance over 20 days or, you know, 15 days to 20 days. So what do you conclude from those graphs in terms of the importance of varieties? What do you conclude? Temperature, yeah. You know, yeah. I mean, you know. So I said to them, well, at the end, what did I say? You plant whatever variety you want. Just keep it cold, right? Okay? So, you know. And really, the way they were telling me, oh, no, this variety produces this and that and the other. And it's like, we did, I think, 4 trials. You know, it's like, oh, okay, there's nothing there for varieties. Okay, just keep the bloody things cold. Okay. However, that's for arugula. And I'm being facetious because certainly there are differences in varieties, okay? But amongst those that were being then produced for the industry, the differences were really minimal, okay? Now, however, in the case of broccoli, when we've done variety trials with seed companies, and this is one of the last ones that I was involved in, here we find important differences. And here I want to say also that I worked with a person in the seed company who was a real stickler about maturity. And to do this bloody trial, I had to go to Salinas like 6 times to harvest the 14 cultivars. So just on the day, he would let me know the day before, okay, come down tomorrow because this variety is going to be ready. And it's like, you know, when you make 6 trips down just to get the raw material and then you have to set, you know, it's like, wow, okay. But in the end, I appreciated that very much. Why? Because he really wanted a correct evaluation. And me, I would have said, okay, maybe 3 harvests or so. But right there, we would have then differences in maturity which could intervene on what our perception of the variety was. And he was a real stickler about the maturity. So I know that is actually very good data. I worked very hard on that trial with him. Okay, so what's the point? What are we evaluating? We're evaluating yellowing and also cut-in discoloration. Now these were stored at a higher temperature, 50 degrees Fahrenheit, okay? So usually we don't work at that high temperature, but for the variety evaluation, sometimes we do, okay? So here you can see we have then 2 groups, right? Like 7 and 7, something like that. Yeah, 7 and 14, 14 cultivars. But what you can see then, if we look at, say, day 10 here, they begin then to separate, right? So some of them, even at this temperature abuse, had differences in shelf life, right? Now, if we were at a lower temperature, it would take us longer to perceive those differences, right? But the idea here is to demonstrate that in those cultivars, there is a range. And then if we look at the browning, which in the end can be more interesting because we're using modified atmospheres to control the browning of the broccoli, but sometimes we have mixtures of vegetables and the other vegetables don't respond well to the atmosphere that's good to protect the broccoli from browning. And so what we want are varieties that brown less rapidly, like this one here. I can't even read what that is. It's Expo, okay, for example. So that one took a lot longer to brown than this top one, which was this one, Marathon, as it turned out, in terms of the end browning, okay? Yeah? So right there you can see some spread in the cultivars. Now, do you think that's important? Do you think somebody's going to go out and plant one variety over the other? Probably not, because there are lots of other things that we're interested in the varieties. Their field performance, their yield, all those other things. But sometimes, if they're having trouble with the fresh cut product, then they may want then to plant a particular variety that will perform better specifically as a fresh cut product, right? Okay. So these slides are from Alejandro Tomas, and so in terms of, he calls qualification of varieties for fresh cut processing. So they do a lot of that in the company, okay? And so you have these horticultural traits that you have to pay attention to, right? And then you have your post-processing or your processing traits, okay, in terms of how the product performs, okay? So there's a lot of things there to evaluate, right? Okay. So here he has a couple examples, iceberg and romaine lettuces. And so here you have different varieties, different types of varieties, okay? And talking about the optimal maturity, okay? And some of the defects that you may see in the field in terms of the horticultural characteristics, right? Bruise susceptibility becomes important, as well as the pinking, okay? Some of the lettuces just perform better, and they find that actually the lighter colored tissue performs better than some of the darker tissue. That's what the industry finds. I mean, and the way I do the experiments, I could not tell that, okay? But so what we call blonde romaines, right, okay? And again, with the iceberg, also some of the criteria here in terms of how they would evaluate the varieties, okay? So, and in the company then, they have developed what they call this timeline, right? Where you have many varieties, and what you can see is their evaluations become more complete. And they use, in that company, they use a pass-fail system. So they have a large number of varieties, and they would tone that, or they would reduce that based on their initial performance, where they go in and do a fuller evaluation, for example, and that would be in the middle of phase 2, where they're actually looking then at shelf life, and then they move into the phase 3, et cetera. So at each level, they have fewer varieties. And so this is one of the things when we evaluate varieties. What do we want to do? We want to evaluate lots of varieties, but in a very reduced way, or we want to have a few varieties and evaluate them more completely. And so they do this multi-stage approach, right, to evaluating the varieties, which we have to do in the interest of time, right, okay? We don't want to spend a lot of time in a variety that doesn't perform well in the field, because we're never going to see it, right, if it's not a good field performer, no? So another thing that he talked about was sort of the design. And there are 3 or 4 slides about this. And here I want to say is that I've been out within growers' fields and things, and we're talking about the varieties, and they'll say, oh yeah, over there I've got this variety, I want you to evaluate that, and over here I've got this variety here. And of course the one variety is over mature, but don't worry about that, we'll find a few heads that are not so well mature, right, okay? And so right there, you're stuck because you know that they weren't produced under the same conditions. So you may find some differences, but it may have to do more with maturity, location of production, et cetera. And so trying to have standard procedures and a standard way to evaluate the varieties becomes very important, right? I mentioned that about the broccoli. So they're all planted in one area, harvesting them at the same maturity. And in practice, I can say, and maybe you will disagree with me, but it becomes something very hard to do well, right? So oftentimes we're evaluating varieties, but we're not doing it really well, okay? And so here, all the, procedures for planting, the irrigation, controlling all those things as we would if we were producing for fresh cut and we had one variety, right? But here we're comparing the varieties, and we must pay attention to all these details. So it becomes very, I would say, maybe I'm unlucky, I would say, but in trying to work with the industry sometimes, it was really difficult to even do good variety trials, much less trials on irrigation and nitrogen. I mean, there it was like, that was really a crapshoot. I'm sorry, but I mean, it really was sometimes, Hard to get good data because in the end you realize there was something that, was not done properly or something. And so there goes the whole experiment because you can't be sure. Was that difference due to the factor you're trying to look at, the nitrogen fertilization, or was it due to this other component that was, changed at the last minute? So I don't know about all of you, but I think, to do these trials well becomes very difficult, Hear about how the raw material is evaluated, how it's held, that, all those, what he calls the metrics, okay, what we evaluate, that everything be done in a standard way. Now, am I just, how do you say, whistling here in the dark? I mean, is this something you all do very well? Do you think it's easy to do very well? What do you think? What do you think? Would you agree with me that those kind of things are probably difficult to do well in the industry? I think so, yeah, based on my working with the industry now. But I think that's the challenge is to know, to control the factors that we would be important. And when you think about varieties, okay, the maturity, making sure the irrigation, the water, the harvest is done, all in the same way as he lays out here, right? In order to get valid, to get rigorous evaluations, right? Okay, yeah, okay. So anyway, so then he puts shelf life, his success rate. Okay, so now in the last few minutes here, I want to move on to what are really other pre-harvest factors that are going to impact. And I have a few examples, some that he had pulled from the literature that I was aware of. But here, what I want to tell you, a lot of it is related with lettuce, but there also have been few good studies, especially published studies, in this area that have been done well, okay? And again, we tried, we did more on the variety end, but when it came to fertilization, irrigation, again, the test, I'm not putting some up that we had on lettuce because in the end, I have some doubts because of, problems in the experimental protocol, okay? So anyway, environmental factors, this is some data from them showing these are respiration rates, okay? And so, the respiration here can vary a fair amount depending on, they have spinach and showing just they had a threshold or an average respiration rate, but what you can see is depending on the time of the year, we're going from December all the way through September, that they found that they had peaks in the respiration rates. I don't think they really explained what those were, although he talks about, heat in the field and things like that. But again, those kind of variations due to season, right, that will affect the respiration rates. And as researchers, I remember having a visitor from a company, it was a new person, very, okay, come and visit me and say, oh, I would like you to share all your data you have about variations in respiration rates of lettuces in Salinas and down in the desert, right? And I just looked at the person and I said, well, I don't have that data, right? You guys have that data because you measure on a daily basis. I mean, I have snapshots. I have snapshots of information from experiments, but that's your business. You work with lettuce every day. So, meaning you must have that data, right? Okay. And so this is some of the data, some of that variation due to seasonality with the same variety, okay, and similar production conditions. Now, this is from the literature. There are several studies that were done in Spain. So Spain produces a lot of lettuces that go to processing plants in the rest of Europe, right? Okay, yeah. And so there's a group under Maria Isabel Gil, yeah, particularly her group, that have worked and then extended out, right? But they have worked a lot looking at some of the pre-harvest factors. And as far as I know, those are really the most rigorous studies that have been done, okay? And so here they're looking at growing seasons. So you have spring and summer and autumn and winter. So in spring and summer, you tend to have lower dry weight. And why? Warmer temperatures, the lettuce is growing faster, so lower dry weight. You tend to have higher respiration rates. You tend to have more browning, and you tend to have more ethanol acetaldehyde in the bags. Contrast that with the autumn-winter lettuce. You tend to have higher dry matter. It's growing what? It's growing more slowly. So that's one of the key factors about pre-harvest factors. Higher temperature, we're going to have more rapidly growing things, right, okay? You tend to have here more CO2, than, okay, in the bags, less browning, and a little bit more ethanol acetaldehyde. I'm sorry, I can't read those here. I have to look on, okay, it's a little bit hard to see. I'm sure it is for you. But the important point is that they use similar packaging, similar processing, and there they were trying to contrast what were the general trends in the behavior of the lettuce from those, and that study is listed. Now,
we have a lot of that data as well.
you do, okay,
We collect
all right,
respiration rate data from all over the world.
okay,
By growing region, by seasonality,
Okay.
and by cultivar.
okay.
That's the database.
Okay, very good. So you have a big database of that. Okay, all right, excellent. That's good for everyone to know. Now, here's an example from a researcher in Arizona where they're looking at rain and microbiological quality on the lettuce, okay? And so they concluded that one is that you had a higher microbial population when you had a rain event, which I think everyone agrees with, right? Okay, just even from post-harvest, we know that. And that also, when you have rain events, you have greater pinking susceptibility. Would everyone agree with that? Yeah. And so, but in the published literature, there's actually little published literature actually to verify that. But I know that that is common knowledge, right? Okay. And then this is from the same study where they're looking at the irrigation, okay? So irrigation termination before harvest, the cutoff date, okay? And so here they had they're talking about outer leaves and head leaves, and they had the irrigation termination the days before harvest. So they went 16 up to at the time of harvest. And you can see the closer the irrigation to harvest, the higher microbial load that they had on the lettuce, okay? Which also makes sense, right? Okay. Now this is one of the studies from Spain, and in this case they had, they did this over 3 years, and they had actually 6 trials, and you can see the trials here, 1, 2, 3, 4, 5 trials, sorry. No, 6, there's the other one, okay? And so you had some variation in the exact amount of water that the lettuce received because it was rainfall as well as irrigation. So as we know, you plan an irrigation experiment, like what happened one time in lettuce, and once you know it rained, we didn't expect it, right? But so that really destroyed the experiment, right? So here they're taking into account rainfall, and that's why within the trials you can see some variation in the total amount of water that was applied, okay? But from one of the studies, what we can see is here we had a certain amount of total water applied, and then we're looking here at the visual quality of the lettuce. So the one that had the most water had dropped visual quality after about 10 days, okay? So there was a major difference there that was consistent. And then here they're looking at off odors, so there were some differences there. And over here they're looking at the browning, okay? So again, the ones that received, in this case, actually, let's see, cut-in browning was greater with also the one that received more water. It's a little bit hard for me to tell. Can you tell the difference there? Yeah? Okay. So again, now this becomes, so you have lettuce, how does this relate to you? I mean, the idea that more water closer to harvest, again, I think is common knowledge, but there's little actual data presented in the literature to sort of to confirm that, okay? But that's what we would expect. I think here the point would be, how important are those differences, right? So, one thing on the graphs they show, well, there's a, there's a difference, right? But one thing is something that's statistically different than the others that's truly important. And that's the other thing in these studies. Sometimes we find differences, but in the end, are they really important differences, okay? And so that's sort of another matter to discuss. Now, we were involved in this arugula. Remember the 4 varieties that, perform very similarly, okay? But when we were doing the trials, we noticed something here. So here we have 2 trials, okay? We did like 4 or 5 altogether, I guess, just based on the varieties. So they were all grown by the same company in the same area, and they were organic growers, okay? So there, the fertilization was, they had a very good control on fertilization, okay? But they told me on this trial, which I call A here, they told me, oh, we had a little bit of problem with the irrigation on this trial, because I went out and I said, well, these aren't ready to harvest. And I said, oh yeah, they're very little tough leaves. I mean, what is this, no? And they said, yeah, well, we had a problem with the irrigation, and we weren't able to irrigate as soon as possible, et cetera. So, we said, well, okay, we'll do it. But in the trial, what I want you to see is, forget the varieties, look at the averages. Let's look at 5 degrees Celsius or 41. In trial A, which had the tougher leaves, smaller leaves, we got about 18 days at 41, okay? And in trial B, we only had 11 days. So what do you think was the difference there? They had it, so fertilization, everything was similar. The difference had to do with the irrigation. So how do you think that affected those differences in the shelf life? It all had to do with this about the dry weight. Trial A, those little leaves had 9% dry weight, and trial B, they only had 6% dry weight. So that dry weight difference really was it. Remember I said these leaves were smaller and tougher, right? Okay. So we know what do. We tend to overwater and over-fertilize. We get big leaves, but they tend to be weaker, okay? So that's one thing, okay? Another is an experiment that we had a graduate student, Trevor Sussel and I, who worked on this about the microbiology and also the performance, and this had to do with spinach. So here it's grown hydroponically, and you have different levels of nitrogen, 75 ppm total N, 150 and 250, and these are comparative micrographs of the leaves, right? Sections of the leaves. And what do you see? More you fertilize, the bigger the cells are, and what that means is they're weaker because you have less cell wall material. So the leaves are more fragile. And we know that also by here on this side, we have nitrogen concentrations increasing, and here we're actually measuring the firmness of the leaves. How do we do that? We have a little puncture test through the leaf. If you ever want to do something incredibly boring and tedious, you want to punch holes in little spinach leaves, okay? We had, thousands of them. Actually, the student did them. I didn't do them, right? Okay, but I mean, no. But you're able to show with the very sophisticated computerized texture analyzers that there's a difference in the leaves. So the important thing about this is what? The implication for the quality. When you have tougher leaves, they're going to not be as fragile, they're not going to break as much. And we'll talk about leafy tomorrow and about spinach. One of the things when you open a package of spinach, what do you notice? Lots of broken leaves, right? The leaves are very fragile, right? So here's where nitrogen fertilization, independent of the irrigation, will affect the toughness and the structure of the leaves, okay? Okay, I only have 2 minutes, so I'm going to skip through this. But here's another. About that same time, I was working with a farm advisor on bell peppers. And we said, okay, we know we have variations in bell peppers and fresh cut. Let's look at, the nitrogen fertilization, because we were involved in that. And I said, okay, let's look at that. But here's the bottom result. Here is the conclusion here. Nitrogen has major impact on bell pepper yield, but not on the post-harvest quality, okay? So, there's where in the leaves, we expect that irrigation fertilization will affect it, but now we're dealing with a fruit on a plant. It's not that straightforward how nitrogen will affect then the actual product that we harvest, okay? And that's just an example, okay? This was an interesting study published in the literature about salinity and how high salinity affected the redness. So this at 20 millimolar of sodium chloride in hydroponic resulted in redder leaves. However, there was a significant yield reduction, 13 to 14%. But you see, there was an ability to manipulate color of the leaves, okay? So it's pre-harvest factors. So just some examples of how those pre-harvest conditions can affect post-harvest quality. And, that becomes very important. And I would say, we struggle with the raw material quality, so it's a matter of asking, okay, what are the most important ways in which the raw material quality vary? Is it maturity? Is it growing area? What environmental factors or what production factors are the ones that are varying the most? And then target those and see, is there truly a difference in the shelf life of the product, okay? And there are some references, okay, here if you're interested, okay? So thank you. Okay.